So welcome to Shardus Q4 2018 update, and we had the Q3 update in 2018, and then during that update we had made some progress, and we also showed what we're working on Q4, and here we are ready for the update of Q4. Without further ado, I'm going to ask the speaker of the day, Omar Syed. I've known Omar for many years, over 20 years. Ever since he's my mentor, and ever since I've known him, he has this entrepreneurial spirit in him, and he has always been looking for new challenges and new problems to solve. And his background, basically worked with NASA, worked at Yahoo, worked at Zynga, worked at national companies. On top of that, he worked on solving many complex problems, very highly scalable, distributed problems, and Shardus is one of his brainchilds. One of the things that I always remind myself that one of his things that he always tells me is how the internet brought the world together and how this is going to change how we look at the financial industry. So without further ado, I'm going to call Omar Syed, the presenter. Thank you. Let's see. Let me just put this on you. Right here. And this should probably go.
That's it. Just stick it in here. Okay. Just clip it up now. Yeah, thanks a lot.
All right, there you go.
All right, thank you very much, Samir. Thank you everybody for coming out. I really appreciate it. We were actually expecting a few more people. They're actually on the way, and so we kept waiting. But we're like, we should get started pretty soon here. So this is the Shardus quarterly update event. We do these every quarter because we want the public to have a perspective on what our project is doing and the progress that we've been making. And like Samir said, we did a previous one for Q3 of 2018, and you can find that on YouTube. There's a Shardus YouTube channel, and if you just search for Shardus, it's up there. So in that one, I covered a lot of the background about how the project got started, how I got started in developing a distributed ledger and so forth. So I'm not going to go into all of that this time, but it's really interesting background information that if you get a chance, maybe check out that video. So as the name says, Shardus is foundation for a global scale decentralized network. So we're trying to build a software that you would need in order to be able to build really highly scalable decentralized networks. Now I was using the word like decentralized applications, but then people kept thinking that we're something like Ethereum, which is, we're not really like Ethereum. We're more like blockchain, in the sense that it's just the foundational distributed ledger technology software, and you can build, a smart contract system on top of this if you wanted to. So I'm starting to change that wording a little bit to be like, foundation for global scale networks instead of applications. So what do we, mean by, global scale? Currently, the only applications that we know about that are close to global scale are things like Facebook and some of these huge social networks like Twitter and so forth. But as everybody knows, these are like very centralized platforms, and people are not happy with that, but they put up with it. But that's because that's where we are in our whole evolution of technology. But in the future, technology is going to allow us to be able to do platforms like that, but in a much more decentralized way, right? So we'll be able to do social networks and things like that. So you can picture there's going to be like billions of daily active users using these platforms. That's going to result in billions of records, millions of transactions per second. So we're starting to think about this technology now, and then by the time we actually build it and get it deployed and things like that, it'll be probably a few years. But you got to start on it somewhere, right? So, and what do we mean by decentralized network? So you could imagine if we had a global currency network. Imagine there was one universal currency that everybody around the world used. If everybody used it, that would be like billions of people using that. You could have like a global identity network. Of course, you would want that to be decentralized and not controlled by any one entity. You could imagine like a global communication network. Right now, we have like very siloed communication networks like WhatsApp and Telegram and Facebook Messenger and things like that. But if there was a decentralized version of this that nobody controlled, I think people wouldn't mind everybody using that same platform, right? So, and then of course social networks and things like shopping networks even. So the goals of these kind of networks is, like first and foremost, in order, to be able to scale. And what scaling really means is to be able to adapt. A lot of times you'll see the word scaling used in the wrong sense. Like a lot of times you'll hear like, oh, Ethereum is more scalable than Bitcoin. But what they're really saying is like Ethereum can process more transactions than Bitcoin, but still it has a fixed limit on how many transactions per second it'll do. So you could just say like Ethereum is faster than Bitcoin, or you could say Ethereum has a higher transaction throughput, but it's not necessarily like more scalable. So in the true sense, like in the distributed systems world, scalability means that your system is able to adjust and adapt to the load that's being thrown at it, and trying to make the best use of the resources that it has available to adapt to the load that's being thrown at it. So that's truly the goal that we want to have, is where the system is has really good scalability. And then the other thing is that you want to maintain decentralization. Like I said, like if you're going to be building these things where you expect everybody in the world to use it, you want to have systems that are decentralized and not controlled by like a single entity. Otherwise, you're just going to be back to square one, right? So decentralization is very important, and like some of the problems that our current systems are having with decentralization is that as these systems are growing and there's more and more blocks being created and more usage is being thrown on these systems, you're having to use like more and more stronger computing systems in order to be able to participate in the network. So you can't just use like a Raspberry Pi or a $10 a month VPS server to join the Ethereum network, right? That's just not possible. You need lots of computing resources. So one of the key things to decentralization is being able to keep the barrier to entry low. So you want lots of people to be able to participate. That's what creates decentralization. Otherwise, if you have like a small number of entities that are only ones who can provide those kind of resources, then even though they're different entities, they may end up knowing each other and colluding and so forth, and so you don't really have decentralization, right? So, like a lot of people will tell you, like systems like EOS, for example, where you only have like a handful of miners, even though they're different miners, they all know each other. Same situation in Bitcoin, right? I mean, there's probably at most like 10 big miners out there, and they all know each other and so forth. So you need to have parties participate who are like who can remain anonymous, who can join the system at any time, pull out of the system at any time. It won't impact the system. So those kind of things are very important to maintaining decentralization. And keeping the barrier to entry low is important so that a lot of people can participate. The other thing, the goal is to try to make the system be very energy efficient. Because in the long term, just the way evolution works and the way systems, they just kind of gravitate towards, more efficient systems winning out over less efficient systems, right? So, if your network is going to need to burn a lot of energy in order to do that consensus, over a long period of time, a system that can provide that same feature but uses less energy, just by the laws of nature, I think will win out. I mean, you could have your views on it, but eventually, that's just how I think, nature works. So we want to build systems that are using much more efficient ways of doing consensus. And of course, while you're doing this, you want to always maintain the same level of security, which basically means that, given that you have, majority of the nodes in the network are honest nodes, then your network is able to maintain the robustness and provide the service. So, so what is Shardus all about? First of all, Shardus is an association. A lot of time people think it's like a company or a nonprofit organization or something like that. It's not. So an association is when a group of people come together to work towards the same goal. So if you think about what was Bitcoin when Bitcoin first started, there wasn't a company called Bitcoin, there wasn't a nonprofit organization or foundation called Bitcoin. That came much later. It was just a bunch of people getting together working towards the same goal. So that's what an association is. And associations actually predate companies and things like that, so they're recognized in law because they have prior history. So Shardus is an association that is building the Shardus software, and we're going to build that as the foundational software that will make it very easy to build highly scalable decentralized networks and make it very easy to deploy those kind of networks. And in building this software, Shardus is distributing a token that we call the Shardus token to the developers and other contributors and promoters of the project. And if you think about it, it's really just a way of tracking the effort that was put towards the project. And we're limiting ourselves to not sell the Shardus token in exchange for any fiat currency or any other token that has established value. So the project itself only gives its token to the people who are directly contributing to the project by making effort. However, those people can then go and sell it to their friends, families, whoever they want, and so this whole ecosystem that's evolving right now makes it possible for people to now be able to sell those tokens on, through like decentralized exchanges or centralized exchanges, things like that. So they're transferable tokens. They're tokens on the Ethereum network. And so what would these tokens be used for eventually? So the purpose of those tokens then, long term, is that once the software is created and made available, anyone that wants to use that software would need to spend the Shardus tokens in order to acquire a license to the software. And the way they actually acquire that license is not by coming to some company or organization and signing a software licensing contract or anything like that. They simply would obtain some Shardus tokens and send it to our contract on the Ethereum network, and that contract would burn the tokens and issue them a license token. And so you don't have to go to anybody or set up a meeting or anything like that to get a license to this Shardus software. You can just do it on your own. Now that the license token that gets issued would contain some string of whatever you specified, and you could specify your company or project or whatever in that. And so it becomes transparent, and everybody can see it on the Ethereum network that, hey, so-and-so acquired a license for this Shardus software. And somebody asked me at another presentation, like, so how are you going to enforce your licensing, software licensing? So we are basically just going on an honor system. And I think the reason why this can work now in this kind of an environment is because of the transparency provided by the blockchain, right? The transparency and immutability provided by the blockchain. So if like company ABC used the Shardus software but didn't buy a license for it, it's very easy for the employees of company ABC to check it. It's very easy for anybody else to check it and so forth, right? So previously, in our current world, you don't know if somebody actually bought the license, right? And because it's such a closed system, but with such transparency, this opens up like new avenues that people haven't really explored yet. So I think just using sort of like an honor system for the licensing could work. Now, for public projects, so the licensing really is for projects that are enterprises and trying to use the Shardus software behind their company walls. But for public projects that want to build, let's say, a social network or something like that using Shardus, now whenever you build a decentralized system, you end up having some sort of a token or coin as part of that system to provide inherent, incentives and things like that. And so what the Shardus license requires is that network to give at least 1% of their token or coin back to the Shardus token holders. So if I'm starting, like, let's say, decentralized Reddit or something, and it's going to have a billion tokens in that network, then 1% of that would be distributed to the Shardus token holders. So that provides a way for the Shardus token holders to receive additional coins into other networks, which would be built on the Shardus software. So this is kind of a diagram that shows basically where Shardus fits in. So Shardus is, at the foundational layer there, and on top of that, private enterprises could build, various different, types of networks that are like federated networks or just limited to the company. And in order to do that, they, burn the Shardus tokens to obtain a license token. And public networks would, give like at least 1% of their token back to the Shardus token holders. And so I've mentioned like Liberdis and Globalville here. So Globalville is actually the project that I started on like years and years ago. And it's basically trying to bring about a universal basic income system based on cryptocurrency, and that has a lot of challenges. And in trying to build that system, I sort of ended up having to build Shardus. But eventually our long-term goal after building Shardus is to build Globalville. But before that, we're doing another coin called Liberdis, which is going to be a coin with the ability to transfer tokens on this network. And we're building that just really as a way to showcase the Shardus technology. But one of the key features of Liberdis will be that it'll be a self-governing system where the holders of the coin or token will be able to decide on the parameters, such as what should the transaction fees be, how much should the miners or the validators receive. Those kind of network parameters can be controlled by the coin holders, so that you don't end up having people fighting over these issues off the platform, and then creating contention and then forks and things like that. So, but yeah, and so also you could build something like a smart contract platform on top of Shardus, and then that could also be having lots of other decentralized applications built on it. And so Liberdis, basically it's a coin and a payment network. Like I said, it's designed for self-governance and sustainability. And by sustainability, I mean, like, if you think about like long-term, can this network continue to operate? Right now, there's a big if for, like Bitcoin. Can it really operate, once, there's hardly any more block reward being given out and the miners have to rely only on the transaction fees? We don't know. And so one of the things that Liberdis does is it doesn't like predefine all those things, but rather leaves them open for the community to set those parameters. So it makes it flexible, and that's because it's more flexible, I think allows it to be more sustainable and adapt. And Liberdis will be built on the Shardus software. The Shardus token holders will actually receive one-to-one Liberdis coins when the Liberdis network gets started. So if you're holding Shardus tokens, then once the Liberdis network launches, for every token that you hold, you'll get a Liberdis coin. And in order to run validators for the Liberdis network, you'll need to stake some of the Liberdis coins to become a validator, and validators will earn, on a daily basis, some coins for the service that they're providing. And Globalville, like I said, is the original project that I got started with, and it's gonna basically need to build a decentralized identity network. So what I mean by a decentralized identity network is pretty much like the holy grail of what the internet has always wanted for identity, right? Like you basically want to be able to have like one digital identity that you fully control, that you can, give certain, properties of that to other places that you register with, and then, you want to be able to retain that control of that, and anything that gets added doesn't get added to like all these different silos all over the internet, but rather it gets added to your identity that you control. But a system like that obviously needs to be decentralized, right? Like you wouldn't want any government or, some company or, anybody to be running a system like that, right? So it's really a very difficult thing to try to build something like that, because you're trying to create unique individual identities, right? So that one person maps to one digital identity. So we've put a lot of thought into how to do that, and eventually when we get to Globalville, we're going to deploy that kind of a system. And it needs to use a stable coin, which we call a GET coin, stands for Global Electronic Trading Coin. And it needs to be a stable coin. You can't have the value fluctuating, because that stable coin is used in the decentralized identity network to provide incentives and disincentives to prevent people from wanting to create multiple identities on that network. And if it's not a stable coin, then those, the reward or punishment for those things could fluctuate. And it's very hard to achieve those incentives and disincentives if the value is always changing. So it's kind of interesting how it ties together. You need the stable coin to have a decentralized identity network, and you need decentralized identities in order to have a stable coin. So it's pretty cool. And so Globalville also is going to be built on the Shardus software. And similarly, the Shardus token holders will receive the GET coin when this network launches. And you'll need to stake your GET coin in order to be a validator for this network. And as a validator, you'll be receiving GET coin. So the roadmap for Shardus, basically, in Q3 2018, we did a demonstration of our consensus algorithm, and showed that part working. And Q4 2018, our plan is to build a distributed ledger, which essentially shows nodes, joining the network, synchronizing, maintaining consensus, maintaining a synchronized state. In the future, then next quarter, actually this quarter, we're working on the transactional sharding. Transactional sharding basically says transactions that come in are going to get routed to different shards, and therefore that allows fewer computers to have to actually process those transactions, and that gives you more parallelism, and you're able to process transactions proportional to the number of shards that you have in your network. And then the quarter after that, we're going to add state sharding. So state sharding says that even the data that the network is holding is now going to get chopped up and distributed into different shards. And so, it'll allow networks to have really, really enormous amounts of data that they can hold, but yet you don't need to have a computer that has 10 terabytes of space on it in order to participate. And once you have state sharding, then it gets really complicated in order to do certain types of transactions where you're spending or involving multiple source accounts, and those we refer to as complex transactions. So the quarter after that, we're going to add the ability to handle the complex transactions. So once that's built, then we have Shardus ready, and then we can start building Liberdis. And so the quarter after that, we'll be working on the core server software, and the quarter after that, we'll try to put together a test net and actually allow people to start joining that test net. And then once we're comfortable with that, then, we launch the main net. So as you can see, like the real application of Shardus doesn't really start until you build something with it. So it's, Shardus by itself is just like a blockchain, right? Like, what are you going to do with the blockchain? You have to build some application on it in order for people to use it, right? So same way with Shardus. This quarter, we've been working on building what we refer to as the enterprise server. So this server is, just a single shard using simple transaction meaning like one source, one destination type transactions. So in doing that, what we're trying to build and show is the ability for new nodes that get started to discover the network, to be able to join the network, to synchronize with the other nodes that are already in the network, to process the transactions. So that's where the consensus comes in. And a natural part of, being a node in a network that has, network issues is that you're going to get out of sync sooner or later. And so the node has to be able to recognize that it's out of sync and then resync itself. Also, Shardus has a concept in there where we rotate the nodes. So the network, one of the features of its scalability is that it auto-scales. So depending on how much traffic is going through the network will look at that and say, well, we only need 100 nodes to process this. Why should we have 10,000 nodes? That's just going to mean that we have to pay all these other validators and increase the cost of running that network. So the network should be able to auto-scale and grow and shrink as you increase or decrease the demand on the network. So in order to do that, we have this concept where the nodes end up rotating. The oldest node in the network gets kicked out, a new node is allowed in. And so even if the network was at a fixed size, you wouldn't have the same nodes running forever. They would be rotating. And that in itself also helps increase the decentralization because you've actually, now the participants are not just the ones that are currently in the networks, but they're really all the nodes that are trying to be part of the network, right? So, and then also you have to be able to boot nodes that are misbehaving or stop sending transactions or just lost their network connection. So the network has to be able to detect those kind of things and get rid of those kind of nodes and keep itself clean. So those things that are in the light gray, we haven't been able to implement that this quarter. We were hoping to get all of this stuff in, but so far we've got the discovery, the join, the sync, and processing the transactions. So also, the way we're trying to design the network is so that it's very modular, so that it's very easy to build, so that if you're the application builder and let's say your application is just a coin, so you install Shardus, you want to build a coin on top of it, it should be very easy for you to just install some software, build your transaction layer on top of that, and it should be very easy for you to create a server from that and just start deploying these servers. And so in doing that, we ended up having to change some of our design decisions as we were going through this quarter and discovering, originally we started out with our software being very Shardus-centric, so that Shardus would tell you what functions you need to provide it, and then it would depend on the application developer providing those functions, and then it would just call those and things like that. So it was very Shardus-centric, and we changed that design now so that it's much more application-centric, where you can pretty much do like a npm install Shardus, require Shardus, and then just pass in your transaction layer to Shardus when you create or instantiate it. So it makes it a lot more easier for the developer, but it makes it harder for us. But we thought that was definitely worth it. Also, we changed our storage model. We were originally planning to use a journaled storage model. That makes it a lot easier to be able to like synchronize, but it ends up requiring you to hold a lot more data. And once we thought more about it, Andrew actually helped us figure out a way where we could use just a snapshot type database and still be able to synchronize, have the nodes synchronize with the other nodes. So these kind of things, kind of set us back a little bit, some of these design changes that we made. And so some of the other things that we've also done this quarter is we've built a network monitoring system, and we'll be showing you that later. But basically it shows you like real time, like we can deploy a network and then watch what's happening in that network as we put transactions into it and see the nodes passing those transactions around. We've had to update our mobile and web wallet. We had actually created that the quarter before, but we've now changed it to work with the new Shardus software. We've investigated using Schnorr signatures. So for our consensus algorithm, there's times where a lot of nodes need to sign off on something to create a receipt to show that this transaction has been accepted. And whenever you have a situation where a lot of entities need to sign off on it, there's ways to kind of crunch that together so that anybody validating that signature only needs to validate one signature rather than say like 50 signatures. So we've been investigating doing that. We haven't actually incorporated it yet, but we plan to in the future. And we did a presentation at the Future of Blockchain conference. We did a presentation at the UTD hackathon for kids developing blockchain projects there. And then we also did an interview on the Crypto Show podcast. So if you go online, you can search for like Crypto Show and Shardus, and you can listen to that. So our plan for the next quarter, actually right now, this quarter basically is, finish up our enterprise server, some of the backlog that we have in terms of, automatically detecting that you're out of sync and resyncing with the network, completing that node rotation and being able to boot lost nodes or misbehaving nodes. And then the other part of it is what we refer to as the federated server, which has the transactional sharding built into it. And so once we add that, you'll actually be able to see like, okay, if we deploy 100 nodes now, and then we break that up into like 10 shards, we're getting 10 times the throughput that we normally would. And this is our token distribution over, since the beginning, and then what happened during the last quarter. So since we started giving tokens to developers for helping with the Shardus project, that's sort of like, here's our estimated monthly distribution and our estimated total, but here's the actual monthly distribution that we had and the actual total. So we're kind of below our targets in terms of the distribution. And the Shardus token, when we distribute it to the developers or anybody that contributes to the price or to the project, we use a price of 10 cents per token. So you can basically take like that, a number for the distribution and divide it by 10, and that kind of will give you an estimate in, like, say, dollar amount, you know, how much distribution is out there. Yeah, so like I said, the token price is basically, so even on the market, it stays around 10 cents for the token price. And there's a current of supply of 8 million, so that kind of puts our market cap at about like 0.8 million. And by the time the project is completed, we figure that it'll be about 40 million tokens that we distribute, so that kind of puts a market cap on the project of about 4 million by the time it's completed. So if we can knock this out in 4 million, you know, Greg here is smiling at me. He's like, yeah, he knows, you know, what kind of valuation projects like this get if, you know, if they're actually able to deliver, right, what they promise. So our core dev team that we have here, actually I want to call them up here. Why don't you guys all come up here? Guys, what happened to Derek? There you are. All right, come on up here. I just want you guys to like meet the core dev team, because these guys are awesome. Yeah, in fact, we were up till 2 o'clock last night getting ready for this demonstration, and they stuck out, and we were all, you know, hung out at the office eating pizza and cranking away and trying to make everything work. So we have Andrew Foster. Andrew, I've known him from my days at Zynga. Andrew's a hardcore game developer. He worked for Ensemble Studios. He was one of the AI programmers for Halo Wars. He's worked at Zynga, worked on the team that built Castleville. So really awesome programmer. And Samir's worked at Yahoo, Cisco, several startups, and Samir was in charge, well, he was part of the team that was in charge of Yahoo's front page data analytics to process that data and decide like what next news story they should show you and things like that. So he's very familiar with, you know, technologies for crunching large amounts of data like Hadoop and things like that. And recently he's been, you know, diving into blockchain technology, and, you know, he's gotten like very, very familiar with, you know, Hyperledger and Corda and Quorum and Solidity and all that kind of stuff. So he's basically like an expert on blockchain now. And then, of course, Samir told you a little bit about me. And then Amer, actually my son. So Amer is kind of a bit of a fresh out, but, you know, don't take him lightly. He, you know, like aced the security exams, you know, those CISSP or whatever, and the GSEC. They actually invited him to be on the board for the committee because he like blew away that exam so good. So we have, you know, a really good security guy on our team. And Derek, so Derek is, you know, just a kick-ass programmer. I mean, unbelievable the kind of stuff he's building. And, you know, he's been programming since he was like 10 years old. And just, you know, like, I just have to say, like, hey, we need this, Derek. And, you know, he loves like going code it up and, you know, like have it done. It's like, here you go. I'm like, wow. So we have a really awesome team. And then we have a couple more guys that are overseas that would work with us continuously. And we also have about 8 more developers that we use on a contract basis. But this is our core team. So thanks a lot, guys. Yeah. So now we're going to start getting into the demonstration part of the presentation. So if you guys brought your, like, you know, mobile phones, You can pull them out. We have an Android app on the Play Store. So if you have an Android phone, you could search for Shardus and download that app. But if you don't want to install it, or you have an iPhone, you can just go to w.shardus.com, and we've also built a web wallet, which provides the same functionality. So while you guys are getting that set up, I'm going to talk a little bit about what we're going to be demonstrating here. So we're going to be launching a network of about 20 nodes across 5 data centers, US East, US West, Europe, Asia, and Canada. So you're going to see that network get launched while we do it in real time. Now we're using AWS T2 micros. And anybody that's used AWS knows like this is like the low end of what you get on AWS. And you're gonna say like, why are you using such like, low end hardware? Well, part of it is because we wanna make sure that what we're building can be run with very low resources, right? So a T2 micro, you only get like one thread, actually. You don't even get a core. It only gives you one thread. It only has 1 gigabyte of RAM and a 10 gigabyte SSD drive. So it's pretty low end system. So we're going to be launching 20 of those in the 5 different locations, and then plus there's going to be one seed node, which provides the initial point of discovery of the network. And we wanted to get 200 transactions per second, but we're not there yet. So we might be able to get, maybe 20 or about 50 transactions per second. But eventually, we want to shoot for higher numbers on that. So here's a diagram of what the setup looks like. So after you install your mobile app or use your web wallet, your wallet will be connecting to a gateway server, and then that gateway server knows the IPs of all the nodes that have been launched, and so it'll route your transaction to one of those nodes, and then that node that receives it will pass it on to other nodes in the network, and then the network will do consensus on that transaction and then change its state. And then we have a monitor server where all these nodes are reporting to that monitor server what their state is, and so they're doing like a 1 second heartbeat of what's happening on that server. And then we have a web front end where you can see all of those nodes and what's happening with that. And then we have these command line client and a stress test client that we use to like inject transactions into the network. So let's get started. Oh, so we don't need to go to that one yet, but we can stay here. And Derek, you want to see if you can put up what the network looks like? So this is going to show you sort of, it's not an exact replica of like, this node is actually here on Earth kind of thing. The nodes are actually going to cover the perimeter or the circumference, and the position the node takes is determined by its node ID, approximately. We adjusted a little bit so that they don't end up on top of each other sometimes. And so now you saw that first seed node get started. Now it's ready, so it's in that green state means that it's active. And you'll notice that there's like 3 circles inside of that node. So those 3 circles are basically we've colored hashes to show like what's going on inside that node. So the node reports back like 3 hashes to tell us what its internal state is. And we've just kind of color coded those hashes so that if, you can easily see nodes that are, reporting the same hash versus nodes that are not. So maybe you want to start launching nodes in other data centers? So when the nodes first launch, you'll see them as a gray color. And what that means is the node isn't actually in the network yet. It's outside the network, submitting a transaction to join the network, right? So this is part of the whole, Shardus concept of, like, you just can't join the network. The nodes in the network have to allow you to join the network. So that actually kind of helps with like a Sybil attack, where like if somebody had a botnet with 1 million nodes in it, they can't just like throw all those nodes into your network and take over. They would just be like spinning their wheels trying to get those nodes into the network first and wasting a lot of time and effort that way. So Samir just launched some nodes. Those nodes are trying to join. Once they got a notification that they've been allowed to join the network, you see them move over to the circumference. And at first there'll be like a yellow color. So that indicates that the node is synchronizing with the other nodes in the network. And so currently, the seed node is the only node that's in the network. And so they're synchronizing with the seed node. But once other nodes are in the network, they could choose to synchronize with other nodes. And so once a node synchronizes, you should see it change to a green color. You're going to start some more nodes and some more data centers? All right, cool. Yeah, so a few more nodes just synchronized right now. And it's important that these internal state colors are basically the same across all the nodes. So you just saw that change. And just, basically this helps us make sure that no node has, gotten like out of sync with the rest of the network. So this tool was very useful in helping us debug things just visually, because otherwise you have to go like through log files and looking at all these long hashes and things like that. So this tool's been like really awesome. Okay, so we've got more nodes coming in and synchronizing. So we're up to a total of 13 nodes in the network now. We should be getting about 8 more coming in.
No, are these actual nodes out there?
Yeah.
So this is not just your demonstration?
No, this is not just like, it's not just like some simulation running. He's actually launching these on AWS.
Are these nodes held by somebody out there?
Excuse me?
Are these internal managed nodes, or are they held by somebody else?
No, these are owned by us though, right now. So they're not like, other people aren't launching this, but once somebody uses Shardus and builds an application and they release that server, then obviously, people would be able to download and launch their own nodes. And this network here, it's gonna implement a very simple coin transfer, right? So like, otherwise, you couldn't really use it. So that app that you downloaded basically will allow you to transfer coins, but in order to transfer coins, you got to have some coins, and so that app also has a tab on there where you can just click that and say, give me like 10 coins or 20 coins or whatever. So you'll need to like create some coins for yourself, and then you can like scan your neighbor's QR code and then transfer the coins to them and things like that. So once we get the network going, then we'll start up the gateway server, and then you'll be able to start putting transactions into the network. So we're almost there. We need about 4 more nodes coming in to the network. Yeah. I mean, so T1 or T2 micros are like really, really low-end computers, and they actually we notice a difference when you're trying to launch those versus trying to launch the more powerful nodes. So who's sitting there sending transactions? Say you ever? Okay, so maybe you want to bounce the gateway server. I think it's probably already up. So you want to bounce it so that it gets the new IP addresses of these nodes, but maybe hold off just a little bit. There's one node that hasn't, or no, there's some more nodes that are coming close and joining. So whoever submitted those transactions, you're going to lose your coin once he bounces the server. So yeah, this is actually happening, and then, so yeah, the setup is, basically we've got 5 locations where in each location we have like 4 nodes, and then, everybody's using their, mobile phone to submit a transaction. It's going through a gateway server, getting routed to one of the nodes in the network. That's where it gets like passed around. They do consensus, and then you're able to monitor what's happening. Okay, looks like our network is up there. So, Amr, did you bounce the gateway server?
Yep.
Oh, okay, cool. So go ahead and try to create transaction or some tokens for yourself. And like once you hit submit on that, you should see something happen over here. You'll actually see your transaction get routed. Now these nodes, they're obviously synchronized right now, but if you really start pushing the network, you start hitting, some of its physical limits, like, it obviously has limited bandwidth, limited memory, limited CPU. And so it's not able to sometimes keep up with the transaction throughput, and a node could get out of sync. And it might happen. So you might actually see that happen. But when that happens, the plan is that a node would recognize that it's out of sync by, checking what the hash is with the neighbors, and be able to then resynchronize itself. Andrew, you wanna maybe turn on some of the stress tests and start hitting the network with some more transactions? So Andrew's gonna run the stress test program, which will start bombarding lots of transactions into the network. And while that's going, you should also be able to submit your transactions, although you won't be able to tell which one is yours anymore. That's not very many, Andrew. What are you running it at?
Oh, it's going now.
Oh, it's picking up. Okay, gotcha.
They were in the queue for a little bit.
Got it. Okay, so he's picking it up. So the nodes are, getting those transactions, bouncing it around in the network, and eventually, once that, stress test stops, you'll be able to see that hopefully all the nodes are still synchronized. And the other thing is that we can't really show you the full detail of exactly how things are working in the real world, because if we were showing that, then this thing would happen so fast you wouldn't see anything, right? So this is sort of a slow down animation of what's really happening. But these are real nodes, and those are real transactions happening. So So how many total transactions, Andrew?
Like 200.
Okay, so 200 transactions just pumped into the network. And looks like the stress test is finishing. Okay, so if we hold off on like any more transactions, we should see these guys synchronize and come to the same color, or we see them get out of sync. So what happens is like the nodes sometimes end up having a queue of transactions that they need to go through. So does it look like some of the nodes got out of sync here, huh? I think it's taken a while to finish the queue. I think the nodes should have finished going through the queue. But, okay, so, so in this case, we had some nodes get out of sync. Now, we haven't implemented the resync part of, this system yet. But you can tell, like there's partitions of nodes, right? Like, so some of these nodes are all the same, and then there's, other nodes that are same, and so forth. And so these nodes will resolve that and resynchronize. But since we haven't implemented that part of it yet, you can actually see that, what would actually happen in a network when it, sometimes gets stress tested and it'll get out of sync. Okay, so let's see. Did we want to show something else, or is kind of?
This kind of sums up.
Yeah, this kind of sums it up, right? Okay, cool. So the next thing we're going to do is basically, help you get some free Shardus tokens. So if you brought your mobile phone with you, just go to bounty.shardus.com, and there's a form there. You can just fill in some of your like your Twitter handle or whatever, and once you submit that form, be sure to use promo code 2018 Q4, so we'll give you more tokens based on that. And yeah, so that way you'll end up subscribing to our social media channels and kind of be aware of what's going on with the project. So yeah, so the thing is, we're building this from scratch. So there isn't a line of code in there that is from some other existing project or anything like that. And because we're building it up, we have it all phased out, and you're getting to see really what happens in the lab, right? Things are not always pretty. Things break, and this is what we spend our time on, is figuring out how to make sure that those nodes would stay synchronized. And hopefully next quarter we'll have that resyncing implemented, and the node rotation, and some of the other things implemented. So we'll be able to give you a even better demonstration at that point. So any questions for me? Gary, I know you always love to ask questions.
Yeah, so, I'm not a technician, but one of the things that seems to be an endemic problem with these distributed networks is undistributed networks, where people get together and they have too much clout.
Yeah, absolutely. So,
Let me finish the question.
yeah, okay.
So I liked,
You get me on my soapbox.
I liked, number one, an easy way to kick people out, but have you thought about ways to ensure non-decentralization? For instance, the other day I was reading that somebody's come up with technology Netflix account, right?
Hmm.
Or can you monitor like concerted behavior among nodes and find out from some algorithm whether that's
If they're colluding.
happenstance or intentional? I'm just wondering if you
Yeah.
can start to build in some stuff that gives you kind of automated ways to kick people off the system if they're undertaking concerted behavior.
Yeah, no, that's a really good question. Gary's saying, like, with these decentralized networks, there's a lot of times when, there could be, colluding going on between the participants. Is there any way to, detect that kind of a thing and boot out, nodes like that?
Or just frankly, make sure you don't have related parties.
Yeah. Yeah, right,
Whether colluding
exactly.
or not. I mean, get started before you stop for being get started. Right?
Yeah, and that's kind of the approach that we're currently taking by, trying to ensure that you don't need a lot of resources to participate in the network, that you don't have to, go through KYC to launch a node to, join the network, things like that. That hopefully would allow more people to participate, and that's really where you get your decentralization, is when you have a lot of unrelated parties cooperating and participating in the network. And so...
But Rob, it's really easy to become related, right? That's what trade organizations are and whatnot. So you just kind of get together as people.
Yeah.
All of a sudden you have a coalition which is attacking you.
Yeah, and that's also where, like, the rotation helps. So, the oldest node is going to get kicked out of the network, and then a new one joins in, and so forth. And so even if you have, like, say, a network of 100 nodes, there might be another 100 or 200 nodes sitting on the outside trying to join. And so it's not just those guys, And so, the more people that are participating and trying to join, that actually increases your footprint of, how much decentralization you have. So.
Just saying, the more you can do to show people that you prevent related parties acting, I think the more you're going to, number one, have a robust, appropriately behaving network, and you're going to have more people interested on the thesis of decentralization.
Yeah, absolutely. And, being able to auto-detect those kind of things, it's probably like, version 2 kind of a thing. But still, in version 1, we want to do whatever we can to promote decentralization. So
one way of doing that is to make sure that the nodes that are going to accept the transactions, and then they are chosen randomly. When you use the random algorithm, make sure that those even in the federated node, you can still pick them up based on that algorithm, and not anybody can, so that people don't collude and make that decentralized.
yeah, absolutely. And so, how you decide to allow nodes to join your network, can also be used to prevent, one party or a group of colluding parties from being able to get into the network. But yeah, these are definitely, like, really difficult problems to solve. But over time, I think, as people work on these, we'll get there. Any other questions? So, all right, guys. Thank you very much for coming out, and hope you learn more about what Shardus is doing. Like I said, you can go to www.shardus.com, and there's lots of information there in terms of a FAQ, a wiki. We have our white paper there, and you maybe join our social media channels. We haven't done a lot in terms of promoting ourselves yet, so we're still kind of a stealth project almost. But, you know, we really don't want to, like, you know, blow the lid off until we really have some really solid technology that we can demonstrate. So, but yeah, look forward to hopefully seeing you guys again at our next presentation. Thank you.